So you can send another file. I have sent it to because I think in the doc file it has not been come money not has been will come in all the equations properly. So now in this file, in the PDF file, you can see the equations. Have you seen that?
Yes.
So can you share that?
I sent a PDF file in the group. Please download it.
So the doc file, the equations were not coming up properly. So now you can see in the equations PDF files. Can you see that? So you can see that there were 3 station data, and each one has a 3 component, right? So the first one is always the time. The second column is the north component. Third is the east component, and the last is the vertical. I think that's the nomenclature. So we have the data from the 3 stations, and I will already give you the latitude and longitude of the earthquake. Okay, the way the earthquake has taken place, and also you have the latitude and longitude of all the 3 stations. Right? So what you need to do is to calculate the azimuth and the back azimuth of the stations, right? With respect to the origin or the source part. So from the earthquake source to the site, you need to calculate the azimuth and the back azimuth part. Okay. Now, the azimuth and back azimuth, I have already shown you in your class of the first day how to calculate azimuth and back and azimuth part. So I think we think that you don't have the lecture notes there. So, but I can upload it into the Google Drive today, all the lecture notes, so that you can have an access in the next day. But I have given you there is a website. It is called ID's website. In the link, there is a ID's website is there. The second link, you can see the link, right? Okay, so you can see this link, right? So this link will be given you so this is the service.iris.edu, and this if you can click that link, so it is giving you first you have to give the site latitude and the site longitude. You have to change that because don't give the 16.154. I do not know whether that's one station is like that or not. But so give the station latitude and the station longitude, and even latitude and even longitude, and then you click it. It will be giving you azimuth, back azimuth, distance, and all these things. right? So it will be very easy things to do if you have this link. So you just write this link or copy this link on your web browser and then change the values or the side latitude and side longitude and event latitude and event longitude and enter it. It will be giving you the distance and azimuth and the azimuth. Have you got it or not?
But upon clicking the first link,
No, first link no. The second link first. You got it or not? So they are giving you the back azimuth.
yes, sir. Changing the black azimuth to be only 1
Right. So basically, every station and the source location, you have to give that latitude and longitude of that place. So that you need to know, right? And then you can calculate from the station what is the back azimuth and what is the right. So if you know the azimuth, then you go back to your equation here. So then you go back to this equation. So RT equals to M to D, A into E, right? Also, it is a matrix of NE. Is it okay? So R is the radial component, T is the transverse component. So radial component is equals to M to the NE. So M is the north component and E is the east-west component, right? So this is north, south, and east-west. And you put this M to D equals to cosine of azimuth, the sine of azimuth, minus sine of azimuth, and cosine of azimuth, right? And then you multiply the matrix multiplication. So then you can say that R equals to the north of cosine AZ multiplied by east of sine AZ, and then transverse equals to minus of north into sine AZ and these numbers. Does it make sense? So it is just a matrix multiplication with the two, but a 2 cross 2 matrix. So you just multiply it, and then you can get your but your data is already there. The north and east data is already there. So you can you have a north component data, your east component data, then you can calculate R and B, right? Is it possible? So can you do this and let me see when we are done. So calculate the R and T and plot both the north component and the radial component, the transverse component and the east component, and give me the result. So either you use the Python or you use the thing, so you want to do as much as Anybody has any other difficulties to understand the thing? So if you can see this plot, you can understand that this is the source and this is the station location, and at this station location, this is the north and east data file, and then what we are trying to rotate it to the R and T, right? So we need this line location with respect to the north, right? So that's the main part, and that you can see that this is the azimuth and this is the azimuth of the data. So this is the event. So that means this line going to the event side, and this line going to the instrument or the recorder side, and this is the north. So if this is their location of earthquake and this is the instrument recorded, so I need to know this is your back azimuth and this is your azimuth part. Is it okay? So if you can go to this website, service.iris.edu, and this is the rotation.doc into the help. If you can take this, can you see these things or clearly or not? What's the web address? The web address is the service.iris.edu, and then iris ws web service iris.ws /rotation/doc/1/.
I repeat, this is a service.iris.edu/irisws. IrisWS means Iris Web Service. Then slash, it's a rotation, full word, and then docs, documents, docs/1/help. So if you can type these things in your web browser, then you can see all the details about how to calculate it. So have you written any MATLAB code? Yes. So let's start. Yeah. Not opening? Hmm? So, ah. So azimuth is okay. So azimuth is minus 20, and that is what when it is coming from there.
Station
K220. So that is coming there. Okay, and
this code is in Python.
so this code is what?
Is in Python.
Oh, the Jupyter has given you this code. Okay, so that's okay. And the value matches.
Where is it? I don't see where is it.
No. In that particular website, you can check whether that value matches or not. So what is going on with your MATLAB?
Sir, it's getting closed down. जब भी खोलने की कोशिश कर रही हूँ. So this should I should directly.
So what is going on with you guys? Huh? So MATLAB open किए?
Yes, sir.
तो MATLAB open करो पहले. हाँ तो उसमें क्या दिए? How you have done that?
So
Okay.
we just pasted the code here.
And so now you read the files first. So you need to give that file name and then read the first column as a time, read the second column as a north component, and the third column as a east component, and read those values first. And then from there you calculate the azimuth and back azimuth from that link and multiply it. Okay, see that thing. So what's going on?
So my laptop got
Huh?
switched off.
Switched off. So what is in your side?
So we have got from the website the data for the second one.
For the azimuth 200, azimuth is 200 and the back azimuth is 20 and the azimuth is
148 and
328. And
azimuth, the difference between azimuth and back azimuth should be around 180, no?
huh? Yeah. And so you now need to put the values of so that the particular formula, write down the matrix R and T, M to D, and right. So put the things. So what is your things going on? So how do you open the calendar file?
Just one, two, three, four. Yeah, so this is your, if you can see that this is your azimuth and that is this one. Is this one, and this one. You can see but we are doing the same station. I'm reaching the last one of the station. Just one of these So our this is the worst case so if you go to the text, read that file, and it is an ASCII file, so just read, and then you can define the first column over time, second column with an component, and the third column with the list component, and then you can take the formula starts with the this particular site with this source. So that you only the azimuth, you cannot do the azimuth calculation. So you have to do so first of all, so this is the initial so this is plus minus, right? So this is what we can do that. Next, this is the so this one into your so this is so your efficiency is R will be equals to M multiplied by your cost as in right. So if you multiply this rate plus M multiplied by this one and sign as plus multiplied so what we need to do is define that equals to time history so this is time history this will be the last time like second and equals to time history time is into the start from 3 this one and also we can see the twin which is the time value and the time equals to time history start one and so this time this thing what we do is read or open this time and then read this so we have to first open this one open the time history this complicated time history and first you open it and then run this thing and then remove it from the equation and then walk this is the time so you remove component and then drop time which is transfer speed right and see so you just example so you can show you the activity the activity oh yeah, you need this one first. So can you improve it? So here. So you have need the back as a share, but you can also calculate using this the existing distance. So that means the distance of the laser, but the distance from the source to the site, right? So that also you can calculate. So that's what we this step, but we do not need at this stage. So now you need know the north and east component data and the time values, time north and east component, and then do this matrix multiplication and give the various values. So,
So when reading the data, I could not see. Can you increase the brightness of the thing so that I can see something? Okay, so file name equals to this one, and read table. So it tables the data, right?
Yes, sir.
So first one. So you need the first one, second one, and third one, right? The second one is the north component, and the
Third one is
the
the
east component, and the time value, right? So first you plot it. First you plot the north and east component, and then see how it looks like. So what is going on with you? Okay. So any improvement? Oh, yeah. So you don't have a MATLAB in your computer or in your hard drive? No. Okay. Okay. So for that, how do you read the files? Means shut down? Oh my God.
No, first in the fact. When it's a nozzle, there is a distress in the body. That's the problem. So, we got something or not? No. So, it is when you record it is leaving the file. Is it not it is in the link so that you have this file? No, that is just you can see up to how much it is going. Stations. Okay, so that's fine. So, if you are vertical, what you need to do, you have to calculate the azimuth from that lead first. And for each file, say suppose azimuth 1, azimuth 2, azimuth 3 station, you have to calculate first on this lead. Because you don't know. So from this lead, you must calculate the azimuth 1, azimuth 2. So now it is calculating for 6.54 and 150.05. This is the station latitude, this is the station longitude, and this is the latitude. Now what you are given to latitude. Can you see what is the latitude? Yeah, so this one is 61.323 is the latitude, 200 latitude, right? And this is the longitude, so we have to put that latitude and longitude there. So so 61.323 and 149.99, so that's the number. Let's see. 61.323 and 923, right? So that's your latitude. And your, so suppose you like to go to K220. So K220 longitude is 15404 and 1540453. So that it will give here. So we have to give here. So we have to give this latitude and this longitude, right? Because this different latitude and even longitude is given, so you can see. So 1540, so it has random number, the case is just the number. And let's see. K220 is the number. K220 154, right? K220 is 154. And 15055. So that means this is given to everything. So actually included in this. Right? So then we can use it. And we always give you the azimuth value of 200 points. So I'm writing the this constitution azimuth is this much. 1.0321 and that azimuth that azimuth becomes 216162. Right, and you can also write down the distance in kilometer in the school. The good distance in meter, so you write 20.123 is the kilometer is the distance. So distance from the station to from the source position to the station. Okay, so now you know that. So we record.
No, something went.
No, you can do it like this. So, let's see. Azimuth, let's see, azimuth. So, what? Azimuth 1 is equal to 0, what's the value? Azimuth 1 is azimuth level is going to 200.734. So 200 point. So that's it, right? So that's the azimuth 1. So let's consider the I equals to 1. So we are going to do 1 by. Okay, we're going to do 1 by first. Okay, and I equals to. So modify this one and G equals to G is big, it will be fine. Then you write down the formula that here north equals to the transverse will be equals to this one because we have to calculate the surface. So right now your radius will be equals to or R will be equals to so this will be in whatever you define here. So this is your in but this multiplication values of angular that's all the formulas. So everything has to be multiplied with it. This side off so this is a degree, so be careful of that. So first you calculate RMT and RMT copy. So it's okay. Block is coming. Okay. So this is for now Eastern particle and then the radial you want to calculate in the contours. Yes, that's good. That's nice. But if that's a then उसको कोई नहीं चाहिए. accelerogram. Just yeah, this is the magnitude 7.2 operate in anchoring area in 2003. We have experience monitoring the accuracy of something pretty well. Now, if it is 50 kilometers, that's okay. We have not had a big damage, but it will be devastating afterwards. Yeah, basically, you can see here, just to go to the particular. Yeah, so if you get, yeah, so are you in the master? Oh, that's yeah, you can zoom this part, and you can see here. So what is happening? So, you do it. Just, and I don't know in the past how they do it because I never but if we not deeper, we just put the F I think I've done whatever it is the 200 or something and then you I think it's the so that means it equals to radial component equals to the longest times into the negative last time. That multiplication into the cosine of the azimuth plus with the multiplication with the sine azimuth. Right? And t equals to minus of n. So n equals to all the values from the file, all the inputs needed. So this is our multiplication sine azimuth plus the t dot the cosine. This is R t equals what's the characteristic? So this is the cost rating. And this will make the time easy. And this will make the time easy. Now this will be the So where is the issue?
Station. Right? So this is the okay, we this. So that we can go to the first league. And if we take the first league, the 80, we will get the angle. Right, so that's easy. Okay. So divided majority, and we provided it. And it was is sensing. Right. Okay. And most of the audible transfers really. You see that in the in this file already because necessarily we will go to the reference from all these things. And I try to see that. This file is permanent direction overlapping and the sum this file is and this is a download directory, but if you are working in a different directory, you have to you need to go to that directory so that you can move to that directory so that if you need to how are you looking at the car? So this is your key driver, and somewhere you can see that changes all of a sudden. So that's what this is what is relevant. And if you go to the discourse component, this is where the levels and somewhere you can see the difference in the levels of so that way. And this is the particular. So if you want to see the peak variable, it will be much better to make it clear. Yeah, because that will be much more. So,
Sir, after you have done this, the problem is I'm fixing the ignorance. Yes, sir. There is some syntax error is there. So later, it's like code which is converted to so the inputting of your data file when I'm trying to explain this one, research more than sometimes.
So can you do it overnight and so you but the
And
model?
try to next.
So it is and the things like this are I want everybody to use data and we a lot of work with different. So let's say you taking the snare transform or the master storage and the running on and the snare transform or the linear and transforms and see how the each snare transforms inside. And then also we can calculate all the downstream parameters on the master storage components. That's our starting. So a lot of data analysis will be done with these data sets. So finish one at least in the night and everybody should plot the non-power storage and the vertical fields and so and all the three that is the K20 and K3 the 5 minutes. Right? So this is the station, and then if you can understand this one, then the next day you will be directly downloading the data from the server, where all the actual data is this ID's data server. And I will show you how to download the data from the ID's data server and try to download it as a master storage in this component, and then you can analyze all the things from there. So if any data happens, you want to see the
data and try to process the data, try to get some parameters from the data, you can easily do that. Just log into that IRIS website, which is free, and you can compute all the things from there. So that is your how to extract the FDSN data. I'll show you in the next tutorial. But first is this one and the ground motion parameters and the Fourier transform. These three we first do it with our given data, and then we will be doing the same thing for the downloaded data, and then we will be calculating all other parameters from here. Okay. So it is. But how much time is left? Could you minute okay? So I don't know what should we do. What they will do. But everybody next day, whenever the tutorial, everybody should come with your MATLAB or Python, whatever you are comfortable with, should be in a running mode, because otherwise there is no use of doing the tutorial, right? So you need to come with the preparation of that. You have to do a coding or you have to do say little bit analysis. So unless and until your computer works, then it cannot be done. So you need to have that things. Okay. So what's the news of your side? How far you have done? Huh? When you got it? When you brought those things? Yeah. You just brought the north, south, east, west, radial and transverse, right? Because the vertical is the same for everybody. So,
this is another representation. If the earthquake, so this is the station, and this is the source. So from where the earthquake is coming, this wave is coming at a very certain angle, right? And it is so that is the incident angle. So if you know the incident angle, then you can rotate your so this is the rotation direction and zero receiver. So this is the game which produces the source and then Q and the T. So for that, we need to know items. So your second thing will give you the I, and then your LCD will be giving the this equation. You have I value, the back has value, and that will be LCD and calculate T will be
So now it is a 3 cross 3 matrix, and you have to multiply with this one. Okay, so then you can compute the LQ and T values.
What is the use of this radial and transverse?
Because the radial and transverse will say that, as I told you last time, that we do not know where the earthquake happens, right? So we have put our sensor one in the north south direction, one in the east west direction, but the problem is this, that the station is here, the earthquake comes here, so in this direction there is the maximum energy. So but we have recorded it in these two directions, so we need to rotate it to try to see that which component we can have a maximum thing. So the radial part, if it is then that should be giving you maximum the energy of the P wave.
Signals are comparatively weaker in the radial and transverse as compared to north-south.
Basically, that might be the case. Let us see. Where is so this is 150, right?
Yes.
And this is 150 also, around 150. But this is
the vertical.
This is the vertical. So the radial is more or less the 150, because
there is something
right. So basically, this might be the same values. You can see the maximum peak values will be how much? It will be one will be a little bit bigger than other, because this is which station? Which stations you are plotting? K209. So K209 is almost northeast. Northwest direction from the earthquake. So that way it will be the radial component will have a little bit more energy. But it could happen like this way. Okay, the earthquake is here. Okay, the recording station is here. Earthquake ruptures, but the rupture front is not going towards the station side. It might be going away from the station side. It is in these directions. It may not be in this direction. So in that way, we can understand that the wave is going in a opposite direction. But that's a radial component. So that means that's the radial direction, but it might be going in a different direction. So that depends upon how the rupture is going on. Okay.
So if you have this one, there is a this is this may not be. It depends upon the number of factors. It's not.
No, this is your incidence angle from the money. It will money measured as a vertical part, and so and the line which joining the instrument to the or the money station to the but to the source directions, right? So so that will be the incident angle, right? But you can calculate the incidence angle. Let me see where is that link goes. Oh, sorry, that link is here. Why the link is not active?
So in general, if somebody asks me how to find like angle between what angle of incidence, that I will be. So
yeah, so you can see
I'm
here.
telling radial because like anything that is propagating inside, it is like radially it is.
Yes.
Energy is radially
Yes,
distributed.
yes. Say suppose it is have a different wave factor is here. So if it is a P wave, its incidence angle is equals to 27.7. So it is the if you are trying to do with the P wave, then it is like this. If it is a S wave, then it will be 28.0 because P wave is basically following the
Leading the S wave.
no, P wave is moving like this way, right?
Okay.
So basically the P wave is a compression and rarefaction, so this will be like this. But the S wave is, if this is the direction of propagation, then the S wave is perpendicular plane. So their angle will be a little bit different from the vertical, that will be from this one. So and this is all the, so this is the depth, this is the phase, and then these are the different incident angles. So you need to be careful about which format you are trying to use it. Are you using the P wave to calculate this one or S wave to calculate LQT? So if you are S wave reach LQT, then you need to use the 28.39, not the 27.7, right? So that way you have to calculate it, and it is a deeper earthquake because this 47.3 kilometer is the deep, and so from that you have to calculate the numbers, right? So how does this look like?
Given the color and name.
So this is your, which one? The K220?
North south, and then east west, and then vertical, and then radial, and then transverse.
So the radial is more or the north south east west is more? But which one has a more peak?
North south or radial.
North south or the east west or the radial or transverse? Which has a highest values? In between the north and south and east west, which one is more?
So I think the north, south is more.
North south, it is how much? It is going to be
300.
almost
300 up, but then 300.
yeah, 300 little bit more, and here it is
And 200, more than 200.
more than 200.
Yes.
So, and then if you can go to the radial,
Yes, more than 200, but less than north south.
and the transverse one,
For transverse, approx less than 200 or 200.
and the minus is also the same thing, right? So the north south is giving a little bit more values, right? That's interesting. Okay. Maybe that's the biggest line. Okay. We'll see that things in the next class. So in your seismic data processing class, have you learned about the filtering of the data? The data filtering, has anybody done or not? How to filter out the data? Say suppose, because the time the entire time record, it's basically from point 01 hertz to something around 100 hertz or 200 hertz when a record is there, right? But I do not need that much, because unnecessarily I do not want to, or might be some particular reason I only need 5 hertz data till 5 hertz. I do not need more than 5 hertz or more than 10 hertz. So I need to do the filtering of the data so that all the frequencies above 5 hertz will be 0, and only the frequencies lower than 5 hertz will be passed through the gate, right? So just you imagine a gate. So that means we will be cutting the high frequencies. So that means it is called the high cut filter. So high cut filter means also it is called low pass, because the low frequency will be passing out, but the high frequency will cut down, right? So that we have to apply in the filter setting, and then we can take the filtered data. Sometimes we need the filtered data because we do not need a big frequency data to be used for our analysis unnecessarily. So we will be filter out the data and try to calculate the amplitude values of the filtered data sets. So we can take out filter at, say suppose 1 hertz to 5 hertz, might be 5 hertz to 10 hertz, and try to see how does that looks like in amplitude wise. So we can see, we can already take the Fourier transform to get the amplitude of the high frequency at the different frequencies, but we can also do the same thing by the filtering of the data. So let's see how we can do these things in a next few tutorials. So I want everybody has to be totally hands-on with your data analysis part. If you have got the data, you have to analyze these things and try to extract all the as much as information from the data sets for any earthquake, right? So that is what is main purpose of doing these tutorials. Okay, so we'll see that.
Possibility that shifting of the arrival time period. So in that case, is it necessary to filter out? In a location, we try. It may be a little bit soft filtering because sometimes the noise, if it is a very high frequency noises that are coming into that high frequency noise, we need to eliminate it. So it requires to do a little bit filtering. Otherwise, people might not be very easily visible, but not very big way, because then it will shift the variable place of the actual data. So you need to be careful. So but the high frequency noise, if it is present at the site,
then that high frequency noise you need to cut, but that does not mean you cut all the actual P wave arrival time. So that's also required. So anybody has used the session or the money you use that right session things. Okay. In money in the department computer, do you have that or no? Yeah. तो session है department में? No, in this money. The department of applied geophysics and that.
Yes, sir, we have.
Huh?
We have 2 or 3 Windows system in that we have size. Preliminary work can be done because other things are not very much configured. Yeah. So that is configured for our observatory only.
Okay. Only for your observation. So
next day you should have all the MATLAB and or the Python, whatever you like to use, should be running in your computer. So Mohit is in the department? Or?